All right, so number 5, here we have a complex fraction. So we have a fraction where we have fractions in it, right? We have a fraction in the numerator and a fraction in the denominator. So what we can do with this is, for one is you can think of it as a division problem. You can actually write it out kind of in line as the numerator divided by the denominator. If you want to like do this divided by this, right? If that helps, you can definitely write it that way. I'm not going to do that because when we get to situations where we're adding and subtracting, that could confuse things a little bit. But as long as you keep it in parentheses, that's fine. Like that'll definitely work. So what I'm just going to do is just going to simplify the numerator and the denominator individually, so independently. So I'm going to do that first and that kind of in the same step, but one at a time. So so here, that's a sum of cubes, right? So I could do x plus 2. It's funny that they kind of wrote it out nicely for us as 2 cubed instead of 8. But it's going to be x squared plus, or excuse me, that's where the minus is, minus 2x plus 4, okay? And where we got that is, remember that difference is, or sum of cubes is a cubed plus b cubed equals a plus b times a squared minus ab plus b squared, okay? So in this case, a was x and b was 2, and so I just basically plugged all that stuff in. So then on the bottom here, we have a common factor of x, so it's going to be x times x minus 2. All right, so that's the numerator. Now let's do the denominator. So now here, this is already factored, x plus 2 cubed. So I'm just going to bring that x plus 2 cubed all over here. This is a simple quadratic. It's actually a perfect square trinomial, but so we want numbers we can multiply, or numbers that have a product of 4 that have a sum of 4. So that's 2 and 2. Sign of the bigger number is positive, and the signs are the same, so they're both positive. And there's not really a bigger number, right? So that's a kind of a hint that it's a perfect square trinomial. Okay. So now what we can do is, if we want to, or if it's possible, we can actually reduce at this point anything here in the numerator denominator, anything in this fraction we can reduce, or we can reduce that fraction independently. We can reduce this fraction independently. We still don't want to mix. We still don't want to say, okay, well, this and this cancel, because we don't know. It's a little tricky because remember, we have to flip that guy and multiply. So let's wait on that. Okay, but I do see that I have 3x plus 2's here and 2 on the bottom. So I can actually cross out 2 of those if I wanted to. I'm going to actually rewrite this and then we'll reduce. Okay, so I'm going to put the numerator fraction first. So I'm going to put x plus 2 times x squared minus 2x plus 4 all over x times x minus 2, and then divided by, and then I'm going to put this one, but I'm going to flip it, right? Flip that guy and multiply. So it's going to become x plus 2 times x plus 2 all over x plus 2 cubed. Okay, so now I can match anything on top with anything on the bottom. Okay, so so I am going to cross 2 of these out with 2 of these, so that means I'm going to have 1 left, right? I started with 3 and it ended up with 1. Okay, and then I have 1 of these with 1 of these, right? Let me do different colors here. This can cancel out with the last one, right? So I don't have any more of those left. And by the way, I made a mistake here. This should be a multiplication symbol, right? Sorry, because we flipped it. All right, so now, is there anything else that I can reduce? And I don't see anything. And this, might be good to check the factor, but there are no numbers that have a product of 4 and a sum of 2. So this is not factorable. And so that's as far as we can go. So really our answer is going to be x minus 2, x squared minus 2x plus 4. And then the bottom we have x times x minus 2. And you can distribute the x if you want to, but unnecessary. Okay, so we'll just leave it like that. All right, so that's our final answer, and that's how we divide or how we simplify complex fractions.